Okay, so let's take the second part of the theorem. So the second part says, okay, so part B. So if this okay, sorry. Again, I'll leave it to you to verify the local biholomorphism part, and then the corollary map part of the part A. Okay. And then let's see. Part B. Yeah. Yeah. So maybe if you have. Yeah. Yeah, last time I only showed like the phi hat is homomorphic, but I didn't show the part where if this phi, if this phi is a holomorphism, a local biholomorphism, then the lifting is a local biholomorphism. Together, I didn't show that it's if the phi is a holomorphic current map, then the lifting is also a holomorphic current map. Okay, I'll leave it as a side. Okay. So if this phi push forward of this pi 1, y naught is contained in the gamma push forward of pi 1 x hat x naught hat. Then there is a unique lifting of phi to a holomorphic map phi hat from y to x hat with phi hat of this y naught is equal to x naught hat. Conversely, if such a lifting phi hat exists, then you have that this phi of push forward of this pi 1 y naught is contained in this gamma push forward of this pi 1 of sorry, x hat, comma x naught hat. Okay. Okay. I'll start it proof. Okay. Let's start this proof. Okay. So okay, so yeah, so since we have this condition of this containment, so yeah, so this is like y here, and then we have the space x. Okay, and then this is like the x hat here, and then this is like phi, and then this is like a gamma. Okay, so then. Okay. Yeah, so there's a unique list of this phi to have phi hat. Okay, so this is what we're trying to show. So Okay, so okay, so why it is true? Because so remember we have the topological lifting. It's like topological lifting criterion, right? So it's like I think it's in the previous result we covered. Yes. So if you have this containment relation of this covering of this fundamental group centered at this y naught and then this x naught hat, where this y naught is like where the so where this x naught hat is like the it's in one of the fibers of this x naught. Okay. Yeah. It's like in the pre-image of this x naught under this gamma. Okay. So okay, so we get existence of this because this space they are all locally path connected, so there's no issue for the condition of the theorem, right? Because okay. So then okay, so then okay, then for the actual then what? Okay, so then so then the unique lifting is guaranteed by so we know that by let's say topological or let me see topological lifting theorem. Okay. Yeah, so okay, so okay, so here he said together with part A. Okay, so here he said that okay, so here he says the proof. Okay, so proof but whatever it is zero. And part A the result follows. Yeah. Okay, so let's see why this follows from here. So so by the topological lifting theorem, this is we know that so we know that there exists phi hat, right? Where phi hat is like lifting, right? So okay, and then for part A, we know that this phi hat is holomorphic, right? Okay, so by the topological lifting theorem, we know that there is a phi hat such that this phi hat of this y naught is equal to epsilon hat. So this is guaranteed by the topological lifting theorem. And then part A says this lifting is holomorphic, right? Okay. Okay, so I think this is being shown. Okay, and then for okay, so conversely, if such a lifting exists, then I think this is true by the converse argument. I think this is true by the converse argument of the topological lifting theorem. I think we have this version. Okay. And okay. Okay. Anyway, let me just follow. Let me just follow here. Okay. So yeah. So that finished the proof of the holomorphic. Yeah. Sorry. Let me holomorphic lifting theorem. Okay. So now let's see what happens next. So okay. So let's prove a corollary. So corollary. So that gamma from x hat to x and gamma check from that's the familiar x check to x be covering Riemann surfaces of a Riemann surface x. Covering Riemann surfaces of a Riemann surface x. Okay. Okay, and then that yeah, covering surface basically is like a whole normal covering space where the ambient space is also a Riemann surface. Okay, and then you let this let x naught in x and you let x naught hat to be in this gamma inverse of x naught. Okay, and then let x naught check to be in this gamma check inverse of x naught. Okay. So then if you have this gamma push forward of pi 1 of x hat, x naught hat is contained in this gamma check push forward of pi 1 x check x naught check. Then so then there exists a unique commutative diagram of holomorphic mappings. Of holomorphic maps, sorry. Okay, so here, okay. Okay, so here you have this x check, right? And then you have this x here, you have this gamma as a covering maps, or holomorphic covering maps. And then, yeah, and then you have this okay, you have this x check and then gamma check. And then you have this, yeah, so this gamma and gamma check, they are holomorphic covering space. And then, oh, they are covering one surface, yeah, so, okay. And then this, you have here, this as gamma hat. Okay, so with gamma hat of this x naught hat is equal to x naught check. Okay, so moreover, if you have if okay, so if this gamma pushover of this pi 1 of x hat x naught hat is equal to the gamma check pushover of this pi 1 x check x naught check, then okay, so then this gamma hat is a biholomorphism. Okay, so this is like the alternative, like the holomorphic version of the, I think, corollary 10.2.6, right? So if you have this, yeah, so basically you have, okay, So if you have these covering maps, and then, so there's a unique commutative diagram, like that, And then if you have these, if you have them equal, then it's a biholomorphism. Okay, you show that. Okay. Anyway, so let me just let me okay. So let me okay. So that is the two coverings. Okay, are holomorphically equivalent. Okay. So okay, so in particular, up to holomorphic equivalence of holomorphic carbons. Holomorphic equivalence of holomorphic coverings. every Riemann surface has a unique holomorphic universal covering space. Okay. Riemann surface has a unique holomorphic universal covering space. Okay, so let's start the proof. So okay, so let me see. Oh, okay. Oh, okay. So that's not a proof for this one. Okay. So the proof is that the holomorphic lifting theorem. So this is the theorem we just showed. Wait, what is holomorphic lifting theorem? So I think this is the theorem that we just proved here. So the part A, like the hidden part A. Okay. So the holomorphic lifting theorem. Holomorphic lifting theorem gives the existence and uniqueness of the community diagram. And then, so corollary 10.2.6 then implies that if the image groups are equal, then the schema head is a biholomorphism. Okay, so okay, so let's start. Let's see why it's true. So, so holomorphic lifting theorem gives the existence and the uniqueness of the community diagram. So okay, so let's see why it gives the existence and uniqueness. So okay, so okay, so yeah, so I think part B gives the uniqueness, right, and existence, right? Yeah. Oh, okay. Okay, so we want to show that this gamma is a okay, so so the existence of this gamma is basically given by the fact that yeah, so this one is a holomorphism, right? Wait, let me check. Oh, okay. So yeah, in the previous statement, it's like okay. Okay. Yeah. So yeah. This gamma is a holomorphism, and then we have the containment of the fundamental groups, and then we also have the yeah, we also have the current Riemann surface condition, right? Hold on, do I have the okay? Yeah, and then okay, I think the reason why we are required for it to be a Riemann surface is that yeah. So remember that when we have the topological lifting theorem, yeah, requires the space to be connected, right? So without connectedness, we don't really have a result. So I think that yeah, I think that's the reason why we have to be Riemann surface. Okay. Okay. And then what happened? So, okay. I know that for this gamma is a holomorphism, and also we know it's the fundamental group is being contained in the gamma. The gamma control of the power of x hat x hat x naught is being contained in the gamma push forward of you have a check push forward. So therefore this condition is being satisfied, right? And then since we have okay. Wait. Yeah, I think everything else just follows, right? How Riemann surface of a Riemann surface X. That okay. 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 Yes. Everything else follows. Okay. Everything else follows. Yes. Okay. So yeah. Okay. So right now what we have is that yeah. So right now we have the existence and immediate of the commuted diagram. Then corollary 10.256. Yes. If the image group are equal, then yeah, it's a wait, yeah, it's if the image are equal, then you have this you have a it's a biholomorphism, because if the image group are equal, then we show that it's a homomorphism. Yeah, we show it's a wait, did we? Hold on. So if the image group are equal, then we know that this is wait. If the image groups are equal, then so if the image groups are equal, then okay, so then there is well, okay, so there's if the image groups are equal, then I think wait. Yeah, if the image groups are equal, then okay, you have a reversed map, right? Reverse, and then you have a reverse map. Then oh. So why is same map? Okay, so you have a reverse map. Such that this. Okay, so you have this okay. And then because so you also have that. So this so this is because this gamma hat is a lifting. Okay, so because the wait. Okay, this is because this gamma hat prime is a lifting. So therefore you have this commutative relation. Okay, and then because this gamma hat is a lifting of gamma, so you have the gamma is equal to gamma check composed with gamma hat. Okay, so yeah, so then you have the gamma is equal to, oh, okay, it's gamma composed with gamma check prime, right? Oh, sorry, gamma hat prime composed with gamma hat. Okay, so yeah, so then, okay, so then you plug in the and then this implies that this gamma of x is equal to this gamma of wait, can't say that it's x equal to x, right? Yeah, so here basically we can pick the x here. So this gamma x wait. What do I want to say? So this x here, gamma check of x is here. Okay, so let me just check the okay, so we want to show that this is a real map, right? So what does this one doesn't tell you that it's identity, right? Because okay. So gamma hat. So this is x. Okay, this gamma hat x. Okay, so you have this gamma. Okay. Oh. Okay, so you have this so okay. So you have this okay, so we know that this gamma hat prime of this gamma of